In this problem, we have a pipe, okay? This black color narrow thing that I have drawn is a pipe. The pipe has one end open, this side is open, and a small hole on the other side. So on the right hand side, you have a small hole, and on the left hand side, the pipe is open. That is, if I put a fluid, it can flow out through this open region. It's completely open. There is no obstruction in this side. Now, what is done is this pipe is filled with a liquid of density rho, and the pipe is made to rotate about an axis passing through the left end with an angular velocity of omega. I hope you understand. See, if my pen is the pipe, it is being rotated like this with an angular velocity omega in this fashion. Okay. What would that result into? See, as a result of this angular velocity, there would be a centrifugal force appearing on this liquid, which is away from the center of this circular motion. So as a result, there would be a pressure created on this liquid, and hence the liquid would be flowing out of this pipe through this small hole. Now this small hole has a cross-sectional area of A1. The cross-sectional area of the pipe is equal to A, and the length of the pipe is equal to L. With this information, what you have to do is, you have to first find out, number one, what is the difference in pressure, or what is the pressure created by this angular movement, okay? Pressure created due to the circular motion of this pipe. So you can understand that the centrifugal force acting on this liquid would provide a pressure onto this liquid. You have to find out what is the pressure created due to the circular motion. Basically, what you have to do is, you have to find out what is the difference in pressure between the left end of the liquid and the right end of the liquid just before this hole. Of course, you can understand that as this liquid flows out, the left end of the liquid would slowly move towards the right. So a time would come when the liquid would be up to this portion. There is nothing over here. So that means you have to find out how the pressure varies as the liquid moves towards the right, or as it flows out. So let's say at a certain point of time, you have a length x of liquid inside this pipe. You have to find out what is the difference in pressure between this point and this point at that moment. So how pressure varies as the liquid flows out. Okay, so this is the first part of the problem. What is the pressure created due to the circular motion, and how it varies as the liquid flows out. The second part of the problem is, you have to find out the velocity with which the liquid would be coming out, and you have to find out how the velocity varies as the liquid flows out. Okay, so when the amount of liquid inside the pipe is equal to x, that is the length of the liquid inside the pipe is equal to x, you have to find out how the velocity varies. Okay, so you have to find out velocity as a function of x. And finally, the third part of the problem is, you have to find out the time taken for this liquid to completely come out of this pipe. So there are three parts to this problem. First of all, you need to understand that this problem is very similar to the piston problem that we had solved earlier. Only thing is, in the previous problem, there was a piston and we were applying a force onto the piston to push this liquid out of the cylindrical region. Here, we don't have a piston, but because of the circular motion, a force is created on the liquid on this direction. And this force would result in a pressure, and that pressure would result in the liquid coming out of this pipe. Okay? Try this problem out. If you are not able to do it, we will be solving these three things in the follow-up videos.